Here's a question for the Toboggan review question. First off, we start with acceleration. As you define acceleration, the easiest, fastest way to say it is just to say acceleration is the rate of change of velocity. The word rate is very important because that means it's change in time. Because if you just write change in velocity, that's just momentum. Or alternatively, you can use the equation language. Acceleration is the change in velocity over change in time. That is the rate of change of velocity. Then we come to this. Ooh, man travels down a slope, one part and then less steep. So the slope AB has an angle, BC have a different angle. Friction is not negligible. This is important. So friction is going to be important here as we solve this question. So we need to be very careful to remember there is friction in forces and energy and things like that. So the man and toboggan have a combined mass. The man starts from rest and accelerates. Okay, so starts from rest and 90 seconds later he's 36. So he starts at rest here, and when he passes this point, his velocity is 36 meters per second. And he takes how long to go again from this whole journey? He takes 19 seconds. Okay, so that's all the information we know. How do you find the acceleration from A to B? Well, here, the easiest, most straightforward way is to use Stuva, one of the kinetic equations called the Stuva equations. So what information do we have here? We have velocity, final velocity, we have initial. We want to find acceleration. What other information we have? Time, right? Takes 19 seconds to accelerate from 0 to this. So we have to remember that one of the equations we can use is V equals U plus AT. That is one of the Stuva equations. So we plug everything we know in. Final speed, initial speed, 0, plus acceleration we're trying to find, and 19 seconds. So you find your acceleration, you should get about, plug calculator, I got 1.8947. That is a lot of decimals. I just like to write them all out, but in the final answer, I'll just round them off to either 2 or 3 significant figures. So I'll just have 1.89 meters per second. This is me rounding off to 3 SF. Normally, how would you know what to decide? Well, I like rounding everything to 3 SF so I can see, but if you are not sure, you can always look at your calculated values. You're using 2 SF to calculate values. So your final answers can also be rounded to 2 SF. This is very similar to what we do in labs. How do you know what SF to keep? Okay, so we got an acceleration about 1.89. So that means he's going to slide down this way, an acceleration of 1.89 in that direction. Now, show the distance he moved is 340. So we need to show that this distance is 340 meters. How do we do that? Well, we can use a Stuva again, but we have to use a different one. So we know final speed, initial speed. Let's not use acceleration. Let's use time. And then we need to find S. Oh, but there's no equation that has all of this together, does it? Well, there is. The one that we can use is S equals to half U plus V times T. There's actually many more Stuvas you can use, but here I'll just use initial is 0, final is 36, time is 19. So that should get you about 0.5 times 36 times 19. 342 meters exactly. Wow. The question is, can you use other Stuva and get the same thing? Yes, you could use V square, U square, 2AS. You could use that and say your final is 36, 0, 2, and use your value 1.8947 and get S. The only thing is, the S that you get will be 342.007 meter. So it's almost the same, but what is this? That is because you're not using the full value of acceleration here. So it's actually supposed to have more significant figures, but we don't have all of them. So it's best to, if possible, use the Stuva equation that has exact given value. So the whatever value that the question gives out, not something that we calculate, because we'll lose out some decimal points. Okay, so that's part A. Part B. For the man from A to B, calculate the change in kinetic energy. Ooh. So kinetic energy means up here he's going to have some kinetic energy, half mu squared. Down here we're going to be half mv squared. So the change will then be subtracting both. Change in kinetic energy here will be half m v squared minus half m u squared. Very conveniently, u squared is 0 because initially at rest. So all we have left is half 95 kg. That's the mass of the man and the toboggan together, times the final velocity, which is 36 squared. Here we should get about 61560 joules of energy. Remember joules? Final answer, I can write 2 or 3 SF, no need to write so many. So 61600 if you want to write 3 SF. You can also write 2 SF since your 95 and 36 are all 2 SF, so you can also write your final answer as 62000 joules. Also can. Then they ask us, what's the change in potential energy? Now, potential energy is the change, I'll use P. Change in height. Do we know the change in height? Let's look back at the picture. Well, they didn't really give us a height, but we could find it because the change in height will be this part. Please don't use 340 meters as the change in height because this is the change in height that you want here, from up here to this bottom level. So this change in height will, we'll have to use some trigo to find it as a triangle. So if we say the sine of 40 is opposite over hypotenuse, means the change in height is 340 sine 40. Okay, so we know our change in height. Let's write it down. So change in height will be 95 kg times 9.81 gravitational acceleration, gravitational constant, and what was it again? 342 sine 40. So this one, you get a very messy number. I'll just write out whatever decimals I like first. 873.7. But the final, you can round off to 2 or 3 SF because here you got 2 SF, here you got 3 SF, 3 SF, 2 SF. You can go 2 or 3. I'll stick with my good old 3 SF. So 205,000. Did I write the correct zeros? 205,000 joules. Yes. This is for me writing 3 SF. Next. Use your answers in part 3, so these two, to determine the average frictional force that acts on the toboggan. Wow, average frictional force. Got frictional force? Let's look back. So between A and B, as they didn't say friction is negligible. They say friction is not negligible. Yes, here. Friction is not negligible means as this person slides, it's going to be a frictional force, I'll say small f, that opposes the motion of this person. That friction force is going to cause a loss in energy. So, how do we write that out? Well, the easiest way is to think of what is loss and what is gain. What energy losses, what energy gain. So energy loss, we're going to start off with a potential energy, which that's why we can move in the first place. So we have potential energy that is converted into kinetic energy. So half mv squared minus u squared, change in kinetic energy. And also converted to thermal energy because of work done by friction. So F times distance it traveled, or accurately, displacement. So these are actually all the work done, work done. So if you plug in all the values we know, 95 kg, 9.81. Height, We got our height earlier, right? Actually, you know what? They already asked us to use these values, so we don't have to recalculate everything. So let me just rub this off a bit. Also, by the way, structured questions often build on previous answers. So there's a chance this is only 2 marks, so it would use answers from before. If your answers here are already wrong, it's okay because your answers are carried forward as long as you know what you're calculating. So you must show you're working, must show. So anyway, potential energy, we got 20500, but I like to use my whole numbers, so I'll use 204,873. Just use everything. Equals to change in kinetic energy. I already calculated that here, 601,560. So 61560 plus the frictional force times how far it traveled. So 342 meters. That's how far the toboggan slid down here. Oh, 340 ah. Did I write 342 or 340? 342. Huh. So this should be 342. Unless you round it off. Then from here, we calculate the force. I use whole values, like exact values here and here, so I would get about 419 newtons. The mark scheme will show otherwise. They'll explain like, oh, if you use rounded off values, you get different values, but it's correct as long as you show you're working. So I'm going to write my newtons here. 419 newtons is a frictional force. Then comes this last bit. Parachute opens as it passes point B. There's a constant deceleration from B to C. So what is happening? Go back to the picture. So B to C, now we're down here. So this one is a little parachute that opens. Something like that. So now this person, instead of speeding up, this toboggan is going to experience a deceleration, which means if I say acceleration this way, it should be -3. If you want to think in terms of deceleration, you say decelerate means there's an acceleration upwards of 3. These two are the same thing. The only difference is the definition of where your acceleration is, and then your sign will have to change accordingly. Okay, so we have deceleration here, and they're asking us to find the frictional force that produced this deceleration here. It's kind of hard to use energy because we don't know the final velocity, we don't know the height, we don't know the distance. We can't really do what we did in the first part. So the best way is to use our knowledge of forces, Newton's second law especially, to help us out here. Okay, let me redraw it here. So we have the slope from B to C, inclined at an angle of 20 degrees. I think it's 20, let me check. Kind of hard to do on the screen. Okay, so here is a toboggan sliding down, and it has a acceleration, I'll stick with this one, acceleration of -3. I'm also going to say this direction is positive, so I need to decide my forces later. Okay, so Newton's second law, the net force is mass times the acceleration. So we know the mass, we know the acceleration, we can find the net force. But what is the net force? Well, firstly, there is a frictional force this way. What's going to cause the toboggan to slide down? There is a gravitational force, mg. So this mg actually has a component, well, we want to make it in a straight line. So this mg has a component in the vertical and the horizontal. Okay, so the horizontal part is what's going to cause this toboggan to slide down. So this is mg. Here is 20 degrees, so opposite hypotenuse, so this is mg sine 20. If I redraw the free body diagram, it's going to look like this. Here's a point. You have frictional force, and you have in mg here, sine 20. That's a component of weight in that sense. So I define this direction as positive, so this will be positive and this will be negative. So let's write it out. So I have positive mg sine 20 By the way, this sign definition, you just define. Because you can choose otherwise, but your answers will be the same, except that it'll just be a positive negative sign difference, but that's okay. So here we have everything down already. Okay. So let's write out 95 kg times 9.81 sine 20 minus that frictional force. Wait a second. Can I use this frictional force from here? 9419. Don't think we can. This is for A and B. But now we're looking at from B to C. So it's a different region, so we cannot use that, which is why we're trying to find this in the first place. Okay, so we'll leave it there. 95 kg again, times the acceleration, which is -3. Negative just means it's a deceleration. So from here, you can calculate your force, which should be about, oh, I didn't write it down, 9.81 times sine 20 plus 95 times 3. Okay, if I write off everything, this would be 603.75 newtons. If I round it off to 2 or 3 SF, I would get 604 newtons for 3 SF. Oh no, where did I go? 3 SF. Or if you round it off to 2 SF, you would get 600 newtons for 2 SF. So that's the main bit about how to solve these questions. Now, how do we grade it? I want you to take a look at the ECR that I'm going to show you next. Forgot to mention, before we look at the IECR, you need to know how to find and use a mark scheme. So paper.sc is a great site. You type in the physics code 9702. Plenty of past year. These WS things mean what exam season it is. So I'm going to go to spring, which is May, June 04, paper 2. Okay, so here we have the question paper. Very convenient because, wow, last time the papers look quite different. So if I just go to any of these papers, I can click on the pink color hyperlink and click M, or mark scheme. The newer versions will say MS, and you can click there. So you can go find this, which I want to show you. So this teaches you how to look at mark schemes. When you see mark schemes, they are like this. On the right, you will see like B1, M1, A1. What are those? Those are how you can earn marks. So you need to know where these marks are coming from. So this one conveniently shows us how to interpret that. It's a MACB scheme. Firstly, you want to know what are B marks. Those are independent marks usually. You don't need working. You can just write the correct answer. As long as it appears, you get it. M marks are method marks. Okay. You must show your working to get an M mark in this case. And if you don't get your M mark, what's worse is you won't get your final answer mark. So if you didn't show working, you just write your final answer, you won't get it. Okay, they'll say, how you get this? Don't know how you get this. C marks are the fun ones. These are what they call compensatory marks. So even if, let's say you knew the equation F equals to MA, but you didn't write F equals to MA, you can still get a C mark. Right? So here they say, equation carries C mark, the candidate didn't write, but she showed that she knew how to use the equation, then you get it. Lastly, A marks are the ones which kind of top off the whole question. This one, if your final answer is correct, you get an A mark. Okay, so remember how to interpret all these BMCA things. One more thing to know is, you will often see what we call brackets and underline. In brackets, don't worry about the brackets. If you didn't write that, it's okay. Underline, you must know, because in, say, statements and definition, if there's an underlying word in the mark scheme, you must write that word or you won't get your mark. Okay, let's look at an example here. Is there underline? Okay, so scalar magnitude B1AC. Okay, so this is how you can interpret mark scheme. Make sure you know. If you forget this thing, just come back to one of those that have this thing. So summer 04 paper 2, for example. So this is the IECR that I mentioned earlier. It's an amazing resource by Cambridge. Unfortunately, it's not for all questions. This question happened to be the lucky one. It's a PDF file. I'll post it in Teams, or you can try to find the link below and you can download it for yourself to find the IECR. So next page, let's see. Here's a good old question. What I want you to do is you will have to try and figure out how to grade yourself based on this mark scheme and type in your marks here in these boxes for each question. Okay, so the first part, acceleration rate of change of velocity. If you got this or that, you should get a B1 mark, so give yourself a check mark on your working. Part B was calculating the acceleration with our Stuva equation. See, they run off to 2SF. If you use this VAT equation, it's a C1. Remember, C1 is for equation. If you didn't write V equals to AT, it's okay, as long as you show your, you know how to use that equation. And then you get A1 at the end if your final answer is correct. Rounding, don't worry about it. Part B was show that distance moved was 340 meters. This one is a show kind of question, so not a lot of marks, just 1 mark. And that's if you kind of show the process of having a Stuva. See, they have many choices. Show your working and then show that you got any of these answers. They're very generous in this question. 340, 341, 342, 343 is okay. Then part B is the one we did, change in kinetic energy. This, if you show that you knew change in kinetic energy is half mv squared, you get 1 mark. And then 1 for your final answer. 1 mark for your working for potential energy. And 1 mark for your what you call this? Final answer. Now notice how this person did something wrong here. 200,000 joules. Something's not quite right. Look at the working over here. This person did 95 times 9.81 times 342. 342 is wrong. So how? What happened? Do we get the marks or not? Let's look at the examiner comments down at the bottom. So we click that. So this is question B3, part 2. So here. So the person used the wrong value of height. The value used is the distance of the slope. This is incorrect physics and not awarded any credit. But in A, what did this person get? This is not really a change in kinetic energy. So the fella didn't really write correctly. But the person got awarded marks. See, the person only write half mv squared. Actually, half mv squared minus u squared. That is the one you want to write. So part B, the person used wrong physics for height. Is MGS. That's what the person used. So wrong. The person didn't get any marks for part 2 over there. Oh no, sad face. Then moving on to frictional force. Looks like this person also didn't quite get it right. So here, you will use previous values, your previous values. It's okay if they're wrong. You use your own values, you get C1. As long as you know how to do your work done, change, or losses. Here they write it in a different form than what we did. Then your final friction value, if you get any of these, it's okay. So the main idea is just to show your working, and you would get if you use slightly different rounding or values. So 2 marks from here. The last one is also 2 marks. 1 mark comes if you wrote your Newton's second law in kind of this form, this equation. If you show that you knew this, even if you didn't explicitly write out, you get a C1 mark. And finally, if you get your frictional force about 600, or depending on your rounding, 600 or 604, that is also correct. So the nice thing about this ECR is not just a mark scheme, but there's examiner comments for every question. Oops, where is it? And top part here, high, middle, low, it shows you example of students' work. A high scorer, a middle scorer, and a low scorer. How would their work look like? So this high scorer was the one we were looking at just now. This is considered kind of like a moderate question, because this high scorer missed out quite a few points here and there. So look, I want you to look very carefully through the examiner marks, what the student did right, what the student did wrong for this high scorer, and see if your mark kind of lines up with this person or not. If your mark kind of lines up with this person, you're kind of on the high scoring side for this kind of question, this difficulty level. Then if you go to the middle, you can calculate if you did kind of the same mistake as this middle scoring person, then you are kind of around that area, the middle zone. Okay, some mistakes, maybe some confusion here, not sure what is going on. Yeah, this one a lot of people make the error. And lastly, if you're on a low scoring side, you will notice that this person did a lot of things similar to you. So your marks here will be very similar to what this person got. So here, very helpful, even if you got a high score, it's good to read through this because the examiner report will explain what is not acceptable. Oh, acceleration is change in speed over time. Speed, not acceptable. So make sure you don't make that mistake. Then here, they also say what can lead to errors, what to avoid, what to do wrong, what is a arithmetic error, and lots of things like that. A lot of common mistakes that we make. So read through the high, middle, and low scoring examiner report to make sure that firstly, you know roughly where you are and how to improve. Secondly, know points to be careful of and how to get marks. And things to be careful and to get marks, you want to get as much as you can. So, yep. Okay, so that's all I want to show you about this IECR. Now, how I mark things usually goes like this. This is back to the earlier working we did. If you write out the equation, that's great. That saves me some trying to hunt through the thing, and I can give you the C1 mark straight away. But if you don't, that's okay. I'll give you a C1 mark if I know that you know what you're doing. And then the final answer, I'll usually look at your unrounded one, and then if I round it off to the correct answer, your calculation, no problem, it's okay. Then this part, I'll give a check mark. This part is convenient to write in case your thing is in a mess. If you round off wrongly to say maybe 1.97, and who knows where this came from, I will pretend I did not see this. But the examiner that's marking this, well, it depends on their mood. If you didn't write this clearly enough and you wrote a rounding, they'll still deduct your A1 mark. So it's best to double check everything, make sure you round correctly. So here will be a M1 mark. So generally, I've got a Stuva, got about 342, round off to 340. Okay, so that part not so tricky. For this one, the first mark we looked at came from the kinetic energy formula. This part, although it's 0, is important to write out to make sure you have correct physics. That's what the examiner talked about. There's a difference between change in energy and just energy, okay? So you must know change in energy means there should be 2 parts to it. Then, of course, your accuracy mark comes from final answer. Change in potential energy comes from using your MGH correctly. So, like we saw just now, if you use the displacement instead of height, then you kind of lose your C1 mark right here. Okay, and then you get final accuracy mark if you round off to the correct thing. For this one, the first C1 mark comes from if you know how to determine your losses and gains in energy. So this will be over here. Or if you didn't write that out, it can also come from that next line over there. Final accuracy marks from friction. Make sure you round properly, calculate well. Don't make silly mistakes. And the last one, parachute and frictional force. From your Newton's second law, if you wrote this one, you get a C1. This one, not quite. Not enough information. You need to show that there's a resultant force and, of course, mass times acceleration. If you didn't write that, if you show in the next line, that's also okay. You still get C1. Finally, if you calculate correctly, you get in the range of correct values. Based on your previous values, you get correct. Now, the question is, here, if you are, no, not this one. Here, if you previously you calculate wrong and you use the wrong value here, will you still get marks? Well, here you will say error carried forward. Means if you knew how to do this and you calculated this correctly based on your values, you will still get this correct. But so don't give up if you don't know how to do one part. Just write something, even if it's just an equation, whatever equation, just write. Who knows, you might get some marks for working. So that's to say, just try. Don't worry if you don't know how to do it. You might get marks for working. So the best is you want to get 2 marks. 2 marks. I think that's the full marks for everything. 2 and lastly 2 and 1. So hopefully that was helpful in, forgot to mark this B1. Hopefully it was helpful in helping you understand how the mark scheme thing works. and how to do, as a review, kind of a kinematics and energy problem like this. So that's all for this review question. Go practice more question, and please remember to time yourself, do it under exam condition, and then mark your own work.